Hello everyone, Mr. John here from Areteem Institute. With this week's Thursday Tidbit, we're going to be talking about conditional probability. Now, probability is something we talked about a little bit in the past in previous videos, but we're going to do a little review and some extensions of it with our kind of conditional probability today. Quick review, we can generally calculate probability as a ratio. Want divided by total, right? You have a die, you roll a six-sided die, there's a 1 in 6 chance any of the sides shows up, right? So in a lot of ways, the basic probability stuff is pretty intuitive and people can kind of make sense of it that way as well. Let's start with one example of this here. We're now going to do two dice. So we have two six-sided dice numbered 1 through 6. One of them is red, the other one is blue. So we want to kind of just think of this as two distinguishable dice. Of course, they're different dice. We're rolling both of them, and we want to calculate the probability from there. So we can, of course, do this probability as a want divided by total. So we can always think of these, and I always like thinking about probability as this ratio. So how many total outcomes are there here? Well, you roll the red dice, there are 6 choices there. You roll the blue dice, there are 6 choices there. Any of the 6 for the red can go with any of the 6 for the blue. So we have 6 times 6 is 36 total outcomes there. Now, in terms of the situations that we want, remember we want a sum to be 9. So we could start thinking about some possibilities here, right? So maybe you kind of roll a 3, a 4, or 5, or a 6 for the red dice. We'll explain kind of why I'm missing the 1 and the 2 in a second. Because in this kind of list here, I want to combine the two for a sum of 9. So if we have two numbers, a red number and a blue number adding up to 9, we could have 3 and 6, we could have 4 and 5, we could have 5 and 4, and we could have 6 and 3. So just counting these up then, we have 1, 2, 3, 4 outcomes that we want. So this probability is 4 out of 36, which is of course 1 in 9. So this again is the basic probability. There's no conditions or anything here, but we just want to review this basic probability because we're going to extend it in the conditional probability example 2. So what makes something a conditional probability? It's really an extra condition or extra information that you can kind of know about, and then you want to update your probability. So this is why we started with this basic example, because we're going to look at the same setup and the same probability, except given some extra information here, right? What is the extra information we are given? We're given that the red die is a 6. So we know that the red die is a 6. And we again want to ask the probability that the two dice rolls add up to 9 in this case. Now, for simple conditional probability, or in other words, given information, you can probably come up with the answer right off the bat. And so we're going to do this kind of 2 ways as a preview of the next slide. Well, there is one way that this can happen. It has to be a 6 for the red dice and a 3 for the blue dice. So if we just think about the blue dice, we should have an answer of 1/6 here. And so this should be our probability in this case. Now you want to be a little bit careful here. The mistake a lot of times people make is they say, okay, the red dice is a 6 and the blue dice then has to be a 3. So you might think that the answer is 1 out of 36. But this is of course not correct. If you want to think about it this way, however, you can fix it by changing the total, right? This given that the red dice is a 6, this is your kind of new total outcomes, right? Everything is happening in the universe where we got a red 6. So if you want to think about it this way, we can still do want divided by total. And then instead of just 1 out of 36, we have to divide by, well, what's the chance you actually got a 6 on the red dice? It's a 1/6 chance there. And of course, now this matches our intuitive answer that we started with of the only dice that matters, or the only die that matters, is the blue die, and 1 out of the 6 outcomes is good in that case. And so this preview here, right, updating your total, you have kind of a new denominator in terms of the information you're given, gives us the formula that you'll oftentimes see for conditional probability. And this probability formula is here. The probability of A given B is written with this vertical line. So it's A given B in this case is want divided by total. What is the want? Well, the want is both of those things happening, right? It's A given B, so that means both A and B have to happen. So that is our numerator. But we still need the total, the universe, what our given information is our B. So this total here is B in this case. If you remember your set notation a little bit, you could rewrite this as A intersect B divided by P of B. But it's pretty easy, and it's totally fine to think about this as, okay, we're given B, so that's our denominator, and then now we want to know A happening when B also happens, so our numerator, our want, is A and B in this scenario there. Now, I'm not saying you needed to use this formula for the previous question. I think the previous question is easiest just to say, only the blue die matters, 1 in 6 of them work, that is our answer. But let's look at one that's a little bit more complicated. It's still the same setup here, but now our given is a little bit different, and we can't just isolate one die or the other die here, right? So in this case, we are given that one of the dice is a 6. Or really here, you're given at least one of the dice is a 6. So just to kind of clarify this here, let's definitely think of this as at least one of the dice is a 6 in this case. So the blue dice is a 6, the red dice is a 6, or both. And now we want to do the probability that the sum of the two rolls is 9 in this case there. So, right, this is probability that the sum is 9, and then we have, right, the given is that at least one of the dice is a 6 in this case. So writing out our formula a little bit here, I still want us to think about want divided by total, right? So the probability in our numerator is combining the two. So this is the probability that the sum is 9 with, right, at least 1/6. So we have a 6 in that case, and our total here is at least 1/6, right? So we have at least 1/6 in this case here. Rolled in that case there. And because we can't isolate, okay, the red dice is a 6, that means the blue dice is a 3, etc., blah, blah, blah. It's a little bit easier then to use our formula in this case. So both of these times here, right, and you can see a little bit of a shortcut for these because you're going to oftentimes be dividing by the same number always, but just to match our formula here, let's say both of them are out of 36 in this case there. So how could we get a sum of 9? Well, it still has to be 6 and 3, but it could be 6 and 3 red-blue or blue-red. So there's actually 2 out of those 36 outcomes in that case, where the sum is a 9 and one of the two numbers is a 6 in that case there. Now, how many of the outcomes, how many of the 36 outcomes have a 6, have at least one 6 we want to be careful about there? You can do this actually with different methods, but I think an easy way of doing it is, what if the red dice is a 6 and the other dice, the blue dice, is not a 6? So we have 6 and not 6, that's 5 outcomes. Then that could be switched, right? The blue dice could be 6 and the red dice is not a 6, that's another 5 outcomes. But we're missing one final outcome, which is they're both a 6, right? So for this kind of, at least one of the dice is a 6 here. Let me just kind of write this up here. You can think of it as 5 outcomes where one of them is a 6, right? Red is 6, blue is not. 5 outcomes where blue is 6, red is not, and then one outcome where they are both a 6. Meaning our final probability then is 2/36 divided by 11/36. And so when we cancel this out, we definitely get 2 out of 11. And notice that this one was a little bit harder to make sense of. You couldn't just kind of intuitively think about this. I don't even know where kind of 11 makes sense without kind of thinking about these cases, right? 5 plus 5 plus 1. So it's helpful to slow down and use the conditional probability formula for a slightly more complicated question like this one. If you want some intense learning while still having fun this summer, I invite you all to check out our online math camp at Areteem this summer. It's open to middle school, high school students. More information is found in the link below. And if you want something that's a little less intense, but you can practice every day, right? Check out our ziml.areteam.org site. And as always, check back every Thursday for a new math tidbit with me here. Like and subscribe if you're enjoying these videos, and I will see you guys next time. Goodbye.